4. Is this a surd? Is root 4 a surd? Well, root 4 is basically 2. All right? Because 2 square is 4. So if you root 4, you would get 2. Now, let's take the example root 2. Is this a surd? Yes, this is a surd. No, this 2 is a rational number, and root 2 would give you a rational number. Now, we can't express a true value for an irrational number because the digit goes on forever. But the true value of this digit is just root 2. So anytime there is an irrational number with a radical meaning this thing here, this root here, then it's a surd. So surd are just irrational number in the form of a radical, if you want to say, right? This is an irrational root of a rational number, right? So not all roots are surds, right? Only a surd that would yield an irrational number, right? For example, like root 2, right? Now there are examples of irrational number that are not surd, for example, pi or Euler's number, right? But surd is just basically something like this, right? Not all roots are surds. Just whenever the answer here, like for example, this part here is irrational, right? So you could simplify to saying it's a irrational root of a rational number. Now there are certain rules that you'd have to know when dealing with surd. For example, let's say you have a number like let's say you have a number like, let me see. Let's say 18. All right, root 18. Now if you root 18, what would you get? Let me see. Let's see if you root 18, what would you get? Well, you could see that this would go on to some decimal value of a lot of digits, right? Right, and it probably goes on. The amount of digits you put here would be based on the resolution of your calculator or device that you use to compute this. But how do we find the exact value, right? Exact value of something like this. Well, there are certain rules that you'd have to know when it comes to surd. So one of them is that, hey, I could find I could find factors of 18, right? And not just any factor. I want a factor that is basically rootable. What I mean by this is that it could be rooted. All right. So what are factors of 18? Right? You have 18 and 1. You have 2 and 2 and what? 9. Right? 18, right? So you want to look for all the factors of 18. All right? All the factors of 18. But you have to be you can't just look for any factor. You have to look for a rootable factor. Now I see that, hey, 2 and 9 are factors of 18, but 9 is a rootable factor. I could root 9, right? Root like example, you could say root 9 is basically 3, right? So I'm gonna tear this 18 into 2 parts, right? So I could say it's root 18 and write it as a product. It's 2 times 9, right? The still whole is this is still root 18. This is still root 18. But now, right? Now I could split this up. So if you have root of 2 times 9, you could say this is the same as root of 2 times root 9. And even if you root 9, you would get 3. So this simply becomes, well, I'll put a 3 in front, right? So 3 root 2. Now this is the exact value of that, right? Not this value here. This is not the exact value. So whenever you have a number, when you have a radical like this, or a surd, if you want to say, and you want to simplify this or find a true value, well, you could find factors of the base, if you want to say factor of the base, or the radicand. This is the radicand. 18 is the radicand, right? You could find a factor of the radicand, and usually you want to do is look for the highest rootable factor. So I know that 1 and 18 is not rootable. 1, you could say, well, 1 is rootable, it's just 1, but that won't give you the answer. But and then I have the factor 2 and 9. And this is the next factor in line, you could say, right? And if you go farther, 3 and whatnot, or 4 and whatnot, if those are factor, you'll just get lower and lower. But 9 is the highest rootable factor. So you want to look for the highest rootable factor here. Now, we could generalize this rule here. We could generalize this and say, hey, we could generalize this and say, if I have root AB, right? AB in this case, I could just see is going to be 2 times 9 expressed as 18. But let's say you have root of some product, right? This could be expressed as root A times root B, right? And if anyone is rootable, you just root it and simplified, right? So that would basically come into this here. You find 2 factor of the number and you root them. So let's look at the next example. Let's see. All right, so let me just put this here. Let's say this is 1, right? Let's see. You have something like root 2, right? Times root 2 would be answer here. Well, in this case, you could say, hey, this is just something times itself, right? Or you could say this is, let's call this x, all right? And you could see it's just times x again, because we assign root 2 to x is just x times x, which is x squared, all right? Now this just become root 2 square. And you know, if you root a number, then square that number, the number just remain itself. So you could say, hey, the root and the square root cancel out, and you basically have 2, right? And this applies for any number, any situation like this. So I could generalize this and say, hey, if I have a number x, let's say root of x, or let me don't use x because we already said the entire thing is it. Let's say root of a, right? If I say, hey, root a times root a, or times itself, root a times itself, now would be answer here. Well, you'd always have a, right? So this is one rule you could know as well. All right. So let's put this here. So we have 1, 2. You know that if you have some root a times root a, your answer is just a. Okay. Oh. No. Let's look at the next example. Let's say you have something like, I don't know, say 2 root 4 times, let's see, 3 root 9. What would this be equal to? How would you work something like that? Well, okay. Well, we could see, we could root these things. Actually, we could say this here. This is 2 times 2, right here. And this is just 3 times 3, right? So this is 4 times 9. And that would be equal to how much? 4 nines is how much? Well, 4 times 4, it is going to be 36. Yes, 36, right? Now, well, let's see if we could do this in the other way. Let's say maybe your situation didn't had a squareable value under the a rootable value under the root, right? Let's say it was actually a surd. In this case here, this is not really considered a surd because you could actually root it. But let's try to develop a rule. All right, let's see. What would happen if I say, we take the two terms, right? We take this, we multiply the 2 and the 3, and then we could root the 4 and the 9, right? So this would give us what? This would give us 6 here, because 2, 3, 6, and this would be times root of 36, right? And now this would be equal to 6. Root of 36 is just 6. So the answer would be equal to 36. Hey, yeah, you actually get the same value as here. Now we can make a generalized rule. Generalized rule would be, hey, if I have some number, let's say, let's say a root b times c root d, right? C root d, then you could actually simplify this to ac root of b d, right? And you could see it hold true. It hold true. Now, this actually only applies if the index of the radical is the same, right? Or the index of the radicals, or you have many radicals, are the same, right? For example, if you had maybe cube here, you have cube here, then it would work. It won't work for like different index. All right, good. So we have an next rule. Yeah, let's put this here. Or we can say rule 3. Rule 3, all right? Rule 3. Right, which we say if we have a root b times c root d is actually equal to product of ac root the product of bd, right? So let's see, how would we deal with something that look like, let's say, root of, all right, let's say, well, let's use 4 and 9 again, right? Let's look at something that's rootable so that we could verify, right? Now this is actually equal to, I should probably look for better values rather than 4 and 9. Okay, let's see. Look for something that can give you a nice value. All right, we could use the same thing here, and this basically becomes root of 4 divided by root of 9. Right, this is gonna be equal to 2 divided by 3. And you could check. 2 divided by 3 is how much? Use your calculator. And 2 divided by 3 would give you 0.666666 all the way to 7. And you could do the same thing here as well. You could say root of 4 divided by 9. And it give you, well, root 4 divided by 9 will actually give you back the same thing here. The same thing here. Right? So yeah, this holds true as well. So we could say that, hey, if you have a number, you have a root of some fraction, right? Some fraction. You could actually say it's equal to root of the numerator in this case, which is a, divided by root of b, right? So this holds true as well. You could do this. This holds true. So this one was another rule we learned. We could write that here. All right, this is the fourth one. Let's say we have all root of a divided by b, or a divided by b all root, you want to say that, is equal to root a divided by root b. Okay. Now, another one you'd want to know is that you never leave radicals in the denominator. You never leave radicals in the denominator. So let's say you have a situation, you have A, or okay, let's say we have, all right, let's say 4 divided by root 9, right? You never leave something like that. Of course, this is just 4 divided by 3. So let me probably change this 4 into, let's say, 9 as well, right? 9, right? Right? You would never leave this here. Well, just becomes 9 divided by 3, right? Which is just 3, right? But you would never leave in a scenario where we don't have the base being rootable, right? The base here being rootable. You would never leave this radical here in the denominator. But how would you do that? Well, let's say you have a number A, right? And you multiply this number by 1, the number just remain itself. So 1 is like a multiplication identifier. So what you would want to do is try to get rid of this radical at the bottom here, but not to change the value or the meaning of this entire thing. So not if you don't want to change the value of it, you need to multiply it by 1. Now, how do you multiply by 1 and get rid of this root here, right? This radical here. Well, what you could do is say 9 divided by root 9 times you need to multiply it by 1. But in this case, we have to express 1 as something that can get rid of this root at the bottom here. Well, we could just say it's root 9 divided by root 9. Right? Root 9 divided by anything divided by itself is just 1. All right? So this becomes 9 root 9 divided by, well, root 9 times root 9. You can say root 9 square, right? Root 9 times root 9 square. So this becomes what? 9 times 3, because root 9 is 3, divided by 9. Well, 9 and 9 goes out, and you left with 3. Now you see how nice that worked, but well, you would think there's a lot more steps. But hey, what if I didn't had a rootable base? Well, you would see that it actually simplifies the expression much more. So look here, right? Let's say I had something like that. Well, you'd have to do the same thing here. Multiply by 1. In this case, it can just be root 8 upon root 8, right? So I just use root 9 to show that the value you get would be the same. So this is another rule here. This is another rule you have. So let's say we could generalize this into saying if you have A divided by root B, then this is equal to A divided by root B times root B divided by root B. And this here would simplify it into A root B divided by B, right? Now, this when you have the radical at the bottom here, this rule here only apply when there's only one radical at the bottom. Something you can have more than one radical, or something you can have more than one term at the bottom, right? So when you have more than one term, you'd have to do something else, which is basically the same thing, but it's a variation to it. So we could write this into a next rule that we learned. So we learned 1, 2, 3, 4. Let's say the fifth rule is that if you have A root B is the same as saying A root B times root B upon root B, which is equal to A root B divided by B. Why B? Because we know that root B times root B at the bottom is just root B square, right? And this go out, so you have B, right? We did that earlier. Okay. So let's say I have a scenario like this. Let's say I have a scenario, you have 2 root 1 plus root 3. Now you can see in this case, they actually have a radical in the denominator. So we don't want that. We never want a radical in the denominator. So how do we get rid of that? Well, we learned earlier that you can actually multiply by 1 to let this thing hold its true value, but at the same time, hold the same value, I mean, but at the same time, you have to get rid of this here. So what you could do instead is multiply by what's known as a conjugate. A conjugate is that you take this denominator here and you just inverse the sign. You just invert the sign here. So this becomes 1 minus root 3 divided by 1 minus root 3. Right? And then you simplify. We can multiply the numerator, which would give us, well, let me simplify. 2 times 1 root 3. And this is the same as, and at the bottom you'd have 1 plus root 3, 1 minus root 3. Now, if you look here, right, you can actually see that this is a difference of 2 squared, right? But just in case, we could just expand it to say 1 plus root 3, 1 minus root 3. It's a difference of 2 squared, but we could expand it, right? 1 times 1 is 1. 1 times minus root 3 is just root 3. Root 3, right? So I just did that. Root 3 times 1 is just, well, it's plus root 3. And root 3 times root 3. Positive root 3 times negative root 3 is going to give us negative root 3 squared, right? So we know that this and this goes out because positive root 3 plus root 3 is just that. And this just becomes 1 minus 3, right? 1 minus 3, right? Because this and this goes out. So at the top, we have distributed 2, this becomes 2 minus 2 root 3. And the bottom we'd have, well, 1 minus 2 is just, 1 minus 3 is just minus 2. So this is minus 2. And we don't leave this like this here. We could simplify. We could split this fraction. We could say this, hey, this is 2 divided by minus 2 root 3 divided by 2, right? When we could split the fraction here, because it's 2 term divided by 2, we could let each individual term be divided by 2, right? Simple fraction. And this becomes what? Minus 1, right? Minus 1. Should put minus here as well, right? Minus 1. Minus and minus will become plus. This goes out, root 3. So our answer in here is root 3 minus 1, right? So you move all the way from here to here, right? So remember that rule here. Whenever you have something like this, you always multiply by what's known as a conjugate, right? So we can make a generalized rule. Let's make a generalized rule. Generalized rule, if you have A divided by, let's say, B plus root C, right? This becomes A upon B plus root C multiplied by B minus root C divided by B minus root C. Okay, so that's our generalized rule. And let's write this here. So let's see, we have 6. We got 6 rules, right? So we have A divided by B plus root C equals A B plus root C multiplied by B minus root C divided by B minus root C. Okay, and that's all. Hope you enjoy this piece of material. All right, and hope it helped. Thank you.